Let's see Nmos common source cascaded amplifier. So first we need to build a Nmos common source amplifier. Then we need to cascade with another amplifier. So for that I'm going to create a new circuit. And here we need to add the Nmos component. So here this is the monolithic Nmos MOSFET. So I just place this here and I need to connect the two voltage sources. That is, one is the input and another one is the VDS and the VGS. These two are the voltage sources. And here always remember this is the base and this has to be connected to the source. So okay, and Nmos, this is the source and this is the drain, and this one we need to connect to the input voltage sources. And here I need to have one resistor to take the output voltage, and I'm connecting from here to here, and this we need to connect from here to here. This is the simple Nmos common source amplifier, and even I need to connect the ground for these terminals. So okay, this ground is common for this ground is common for all these voltage sources, that is the input and even for this. So this we need to just connect here. This is our simple Nmos common source amplifier. Now we need to define the model for this Nmos. So for that we need to minimum two parameters we require. So dot model Nmos, and here we need the Kp, that's equals to 200U, and VTO, that's equals to 0.4. It's a positive for the Nmos. Now we just place this here, and let's say this resistor be 2 kilo ohms, so 2k, and let this VDS voltage be 1.6 volt or 1.8 anything. We need to maintain this Nmos and the saturation region. That's why we are giving this, and even the input has to be greater than VGS. So here let's go to the advanced, and we need to give the sine wave. So DC offset I'm giving this as a 0.65. okay, let's say, so it has to be greater than 0.4. so I'm just simply taking this as a 0.65, and the amplitude, okay, 1 millivolt as usual, and the frequency will be 2k. And now okay, we are all set to simulate this circuit. So I'm just going to run this circuit, and we need to make the transient analysis. So stop time we will run for 10 milliseconds, and the time for saving is 0, and the maximum step size will be 10. Okay, now if we check at our input, and this is 1 millivolt, and if we check at the output, that is we need to take here, so okay, we are not getting any gain. So okay, let's change this. Okay, let's set this length and the width of this MOSFET. Length will be 1U, and the width, let's say this is 100U. And now if we run this, and we need to look at the, okay, so now we just see, so this is our output now. So our output is from 350 millivolt to 360 millivolt. The swing is from 350 to 360. That means we are getting the gain of 10. So okay, we are getting the gain of 10 because our input is on just the 1 millivolt. Now to cascade this circuit, we need to create the similar copy of this circuit, and we need to cascade its output to the another circuit. So for that, okay, let's make this as a zoom, and I need to copy this. So here I'm using this copy tool, and we can just copy these much things, and we can just have it here. And here, instead of these voltage sources, I'm just no, yeah, this is our input voltage source. So instead of this one, I'm just connecting whatever the output I'm getting from here to this input. So I need to connect from this is the output of my first circuit, that I need to connect to the input of my second circuit. And we need to make sure that all these two circuits will be in saturation region for to the best amplification. Okay, let's run the circuit now and let's see the output. So, okay, this is our output. We'll check at the output now. Okay, this output is 350 to 360. This is the output of our first circuit, and this will be given to the second circuit. And let's check it the output here. So, okay, here we are not getting any output because this is okay. Here the output from this circuit is okay. Let's check it the output of this circuit. This is okay. So this starts from 3 350 millivolt to 360 millivolt, which is less than the uh, what is this VTO, that is, or the threshold voltage for this Nmos. So make sure that here we are getting the voltage which is greater than 0.4 volt, and because we need to maintain even this circuit in the saturation region. Now we are not maintaining this circuit in the saturation region, it is just in the okay, so yeah, it is just in the cutoff region because here our output is just 350 to 360 millivolt, which is not sufficient because it is less than 0.4 volt. So what else we can do now? So let's just change these from 0.65 to something else. Let's say 0.7, and we will see how much voltage it will produce now. Okay, so this is decreasing. So okay, let's decrease this to, instead of 0.65, we just make this as a 0.62, and we will check it now. So yeah, now we are getting from, I just made this from 0.65 to 0.62. Now we are getting from the swing from 32 to 40, 41 something, yeah, 41. So the gain is now 11. Okay, so it increased from 10 to 11, and this is even we maintained in the like 0.4, greater than the 0.4. So now if we check at the output from here, then we are getting a little bit higher values. So let's see now. Okay, so if we just check at the input, this is our input, that is 1 millivolt, and this is the output from the our one circuit. Okay, this is the first circuit, that is, this is our output, that is from 632 to around 640. So 641, that's around 9 or 10, it's a have a gain of 9 or 10, this circuit. And now we cascaded this circuit to this one. So now if we check at the output here, then this would be much greater than the previous one. That is, here we can see this is from 521 to 600. So we are getting the gain of 75 to 76, or as yeah, 80. We have, it's not clearly 80, but we are getting around 78. So the gain gets increased. Here we can see. Okay, so this is what from 1 millivolt how much gain we are getting now. So we can see that this is our input and we got at the output. So this is our output, that's a much more gain than the single circuit. So this is called as the cascaded Nmos common source amplifier. I think you understood this. Thank you.